They're shaded, and then what else is different about them? Yeah, there's, huh? Mm-hmm. You're right. I don't have any tissues. You'll have to go to the bathroom or use paper towel back there. So the shading is different, but what else is different about the lines? There's dotted lines, right? The bottom one has a solid line, but the top two are dotted, right? We've never seen that before. So that tells me that this is an inequality. It's not an equation. But if I want to write the inequality, I start the same way I write an equation. I'm going to write it in slope-intercept form, y equals mx plus b. So that means I need to identify what's my slope and what's my y-intercept. What's the m and what's the b? So start with the b. That's easier to identify. Where's my y-intercept? Good, -2. So b equals -2. And then I look on my graph, I look for another point that's at like a whole number, right? So right here, that looks good. And then I need to figure out my slope. How do I figure out my slope? Good, up 2, that's my rise, over 3, that's my run. So my slope is 2 over 3. And then I can write the majority of my equation, right? It's just going to be y equals 2/3 x minus 2, right? But it's not an equation. It's not just a line. It's going to be an inequality. And I need to figure out, is it going to be less than or less than and equal to, or is it going to be greater than or greater than or equal to? There's 4 different options there, right? Less than, greater than, less than or equal to, greater than or equal to. Okay, we got to figure out which one it is. So do you remember last week when we had less than or greater than, we used an open circle? It's over there on that poster. And then for less than or equal to, greater than or equal to, we use the closed circle. It's kind of similar with our 2-variable graph. But for our less than and greater than, we use this dotted line. And for the less than or equal to, greater than or equal to, we use the solid line. So what does this graph have? Does it have a dotted line or a solid line? Dotted line. So I know it's not going to be this inequality. It's not going to be this inequality. It's either just going to be less than or greater than. And do you think this is shaded above the line or below the line? You think it's above? You think it's below? It's kind of hard to tell, isn't it? Like sometimes it's like very clear and other times it's kind of like, I'm not totally sure. So what we do is we can use a point, just like we did earlier. We're going to pick a point and we're going to test that point. And most of the time you can use 0, 0 as your point because that's the easiest one to use. So if I plug in 0 for x and 0 for y, I'm going to plug in 0 for x and 0 for y. And I'm going to test this point and see if it makes my inequality true or false. Let's try it. So, and first of all, before we do that, 0, 0, is 0, 0 a solution or not a solution, do you think? It's not a solution because it's not in the shaded area, right? So that means that this inequality should be false. Should give me a false inequality because 0, 0 isn't a solution. It's not going to make it true. So let's test it and see. 0 is greater than or equal to, what's 2/3 times 0? 2/3 times 0 is 0, and 0 minus 2 is? -2. Is 0 greater than -2? No, that is false, right? That means that I wrote the correct inequality there. Ah, but no, I didn't. Why did I do a greater than or equal to? Shouldn't have done that. Should have been just greater than, because it's a dotted line. Greater than, greater than, greater than. Huh? Good. Okay, let's try the next one. It's like kind of weird because it gets confusing because, right, for this case, 0, 0 isn't a solution, so I want it to be false. And that's where it gets a little funky, but it'll make more sense the more you do it. Okay, so we start by just writing our kind of standard equation, y equals mx plus b. I got to figure out what m is, and I got to figure out what b is. Where's my b in this one? Good, -5. And then I can use this point up here to figure out my slope. What's the rise of my slope? You guys cut it out. What's the rise? 5. And what's the run? 2. Good. So there you go. That gives me most of my final answer, right? Y equals 5/2 x minus 5. But again, I'm not using an equal sign. I need to use an inequality. So look at that. Is the shaded part below the line or above the line? Huh? Below or above? What do you think? You think it's below? Is it a dotted line or a solid line? Good. Right, so I'm going to use this one. I'm not going to use these. And you said it's below the line or above? I think it's below. So then we use less than. But then we test our point. We test 0, 0. Do you think it's above? Let's test it and see. 0, 0. So if I plug in 0 for x and 0 for y. 0 for x, 0 for y. I end up with 0 is less than 5/2 times 0 minus 5. 5/2 times 0 is what? 0 minus 5 is what? -5. Is 0 less than -5? No, that's false, right? That tells me 0, 0 isn't a solution. Is that what it shows on the graph? Yeah, it does, right? 0, 0 is not a solution, so it should be false in the inequality. Okay, so that's it. That's my final answer. Let's try another one. Y equals mx plus b. What's my b? Where's the y-intercept? +4. Then I can use this point. And then I'm going to use my slope. What's the rise for my slope? Down. You could go all the way to 4. Yeah, down 2. So what does that mean? +2 or -2? -2. And over how many? 1. Right, which just simplifies to -2. And there's my equation. Y equals -2x plus 4. And again, I'm not doing an equal sign there. I got to do an inequality. What do you think? Is it shaded above or below the line? Below. And is it solid or dotted? Solid. So I've got to use one of these, right? Not these. Not those. I've got to use one of these. And we said it's below the line. So let's try it. Less than or equal to. And again, I try out my solution, or I try out my point, and I see if it's a solution. Is 0, 0 a solution on the graph? Yeah, it is. So when I plug it in, my inequality should be true. Let's try it. If I plug in 0 for x and 0 for y. 0 is less than or equal to -2 times 0 plus 4. What's -2 times 0? And 0 plus 4? Is 0 less than 4? Yeah, it is. It is, right? That's true. So I know I chose the right direction. Let's look at the other side, and I'm going to give you some practice problems, but I'll explain what I want you to do for them, okay? It's confusing. It's confusing at first. What we're really practicing today is testing solutions in the inequality. So you're plugging in these numbers for x and y. It really helps to use a calculator. It takes away like the majority of the work from you, okay? Okay, so on this page, for number 1, you're just plotting and labeling each point. right? So remember, x comes first and then y. X is left, right, y is up, down, right? So for A, -4 is 0. I go to the left 4. I don't go up or down at all. I just stay right on the x-axis. And then make sure you label your point as well. You put the letter next to the point. Okay? And I want you guys to do B, C, D, E. And then in number 2, they show us some solutions to this inequality, but we want to test to see if any of these are solutions as well. So what you're going to do is you're going to plug in these numbers for x and y. First number is x, second number is y. Right? So for this first one, 1, 1. Plug in 1 for x and 1 for y. So I end up with 5 times 1 plus 9 times 1 is less than 45. And I'm asking, is this true or is this false? So what's 5 times 1? And then 9 times 1? What's 5 plus 9? 14. Is 14 less than 45? Yeah, that's true. So that tells me 1, 1 is a solution to this inequality. So I want to check that little box. And that's all you're doing. And it's always the same thing. You're always using this inequality. So for the next one, right, you do 5 times 4 plus 9 times 0. And then you check, is it less than 45? If it's true, check the box. If it's false, don't check the box. Does that make sense? Okay. And then in number 3, this is easy. So it just says x is less than or equal to y. And it wants you to come up with 3 pairs that would be a solution to this. So it's just the first number needs to be less than or equal to the second number. That's it. Okay. And then the last thing you're doing is on the right side of that paper, and you've got all of those graphs, right? You have all these graphs on there. Number 1 is the same for everybody. Got y is greater than x plus 4, right? Y is greater than x plus 4. They graphed the line for me, right? My y-intercept's at 4. I have a slope of 1 over 1. And they used a dotted line because it's just greater than, not greater than or equal to. What I want to do now is decide, do I shade up here on the G or do I shade down here on the T? And what I want you to do to figure it out is to take 0, 0, x and y, and plug in 0, 0. If I plug in 0 for y and 0 for x, I end up with 0 is greater than 0 plus 4. What's 0 plus 4? Is 0 greater than 4? No, that's false. That means 0, 0 is not a solution, which means none of these points down here are a solution. I have to shade the side that doesn't include 0, 0. If it's true, then 0, 0 would have been a solution, and I'd shade that bottom side. Okay? Can we give that a try? So whole back side of the paper that I'm looking at.